Hello everyone, welcome back to Piece of Physics. In this particular video, we are going to solve few problems based on the motion under the gravity. Okay. Our first question is: ball is thrown up at a speed of 4 meter per second. Find the maximum height reached by the ball. Okay. So here the object is being thrown vertically upward with the velocity 4 meter per second. So basically, V naught or U is taken as positive plus 4 meter per second. Acceleration is negative, which is minus 10 meter per second square. Okay, so our first equation, like, and at the maximum height, object is going to be at rest, which is 0 meter per second. Okay. So here we are going to apply v square minus u square equals to 2ad. So v is basically 0, so 0 square minus u is 4 square. 2 acceleration is minus 10, and this is d. Okay, so here the 4 square will be minus 16. This is minus 20. This is d. This will be 16 upon 20. This is going to be 4 by 5, which is basically 0.8 meter. So distance is going to be always 80 centimeter. Okay, so the maximum height reached by the object is going to be 80 centimeter. Okay. Okay, our next problem is ball is projected vertically upward with a speed of 50 meter per second. So our initial velocity is plus 50 meter per second. Okay, now we have to find the maximum height reached. Okay, so at the maximum height, velocity is going to be 0. G is taken to be always negative, minus 10 meter per second square. Let us calculate our first part, which is v square minus u square equals to 2ad. Okay, so v is 0 square minus u is 50 square. This is 2, this is minus 10, and this is d. Okay, d is our height. Okay, so this is minus 2500, this is minus 20 into d. Negative negative will be cancelled, 0 0 is gone. Distance is going to be 125 meter, which is basically height. Okay, our second part is the time to reach the maximum height. Okay, so which is basically taken to be v equals to u plus gt. Okay, okay, यहाँ से, so from here we can find the time to reach the maximum height. Okay, at maximum height, velocity is 0, u is taken to be 50, and g is minus 10 t. So basically t will be 50 by 10. T is 5 seconds. Okay, and in the last part we have to find the speed at the maximum half of the maximum height. Okay, so here the maximum height is 125. Okay, so basically we are going to apply v square minus u square equals to 2a d by 2. 2 will be cancelled with the 2. Okay, so v square minus u is 50 whole square. Acceleration is minus 10, and height is 125. Okay, so here v square minus this is 2500, this is minus 1250. Okay, so v square is going to be 1250, right? So basically v square is going to be taken to be 2 into 625. V is going to be 25 root 2 meter per second. Okay, so that will be the answer of the speed at the half of the maximum height. Okay, our next problem is a ball is dropped from a balloon going up at a speed of 7 meter per second. If the balloon was at a height of 60 meter at the time of the dropping the ball, how long will the ball take in reaching the ground? Okay, so consider one balloon like this. This is going upward with velocity 7 meter per second. There is a ball which is being dropped. Okay, like at the time of dropping, the velocity is 7 meter per second and height is 60 meter. Okay, so how long will the ball take in reaching the ground? Okay, so here uh, we have to find the this particular thing. Okay, so let us take this as the reference line. So we are going to apply d equals to ut plus half it square. Okay, so distance is going to be minus 60. U is upward, balloon is going upward, so u is taken to be positive 7t minus half, g is taken to be 10 t square. Okay, g is negative, so negative sign is ahead of the t square. Okay, so yeah, this is 5. Okay, minus 60, this is 70 minus 5t square, this is 5t square minus 70 minus 60 equals to 0. Okay, and now we have to find the time t, so time is going to be minus b. Okay, minus b, so it will be 7 plus or minus b square minus 4ac, which is 49 minus 4 into 60. Okay, so minus minus will be plus, and this is 5 by 2 into 5. Okay, so time is going to be 7 or minus. Okay, so 4 5s are 20, 26 into 60 is going to be 1200 and plus 49, which is going to be 1249 divided by 10. Okay, so now this is 7 plus or minus, this is 35 5 10. Okay, so here you can see that you can take minus 35, but in that case total time will be negative. So here we can take 7 plus 35, which is 42 divided by 10, 4.2 second. Okay, so total time to reach the ground will be 4.2 second. Okay, so that's all for this particular problem, right? So our next problem is a stone is thrown vertically upward with a speed of 28 meter per second. First part A, find the maximum height reached by the stone. Second is its velocity 1 second before it reaches the maximum height. And C is the does the answer of part B change if the initial speed is more than 28 meter per second, such as 40 and 80. Okay. So our first part is we have to find maximum height reached. Okay, now I can apply directly this equation. That's squared by 2g. B naught is basically 28. So this is 28 into 28 divided by 2, 9.8. Right, so this is 28 into 28 into 10 divided by 2 into 98. Now you can see this is going to be 5, okay, 49, 14. Okay, now 49 can be written as 7 into 7. Okay, I can cancel 7 to the this 4, this is 2. Okay, this is 2, 4s are 8, 8 5s are 40. So the maximum height reached is 40 meter, right? And second part is velocity 1 second before it reaches the maximum height. Okay, so at the maximum height velocity is 0. We have to find the velocity before 1 second, that is suppose u time is 1 is taken to be minus 9.8 per second square. Okay, so now let us apply v equals to u plus dt is 0, u is u, and this is minus 9.8 into 1, u is taken to be 9.8 meter per second. Okay, so the velocity before 1 second reaching the maximum height will be 9.8 meter per second. Whatever be the initial velocity, okay, so this is going to be constant. So our next part is, does the answer of part B change if the initial speed is more than 28 meter per second, such as 40 meter per second or 80 meter per second? Do you really think there is going to be final speed as 0, and we have to always take time interval as 1 second? So the answer of this particular part C will be also the same as the part B. Okay. So here our next problem is pretty funny. Okay, so a healthy young man standing at a distance of 7 meter from a 11.8 meter high building sees a kid sleeping from the top of floor. Okay, with what speed, assumed uniform, could he run to catch this kid at the arm's height of 1.8 meter? Okay, so consider one building which is 11.8 meter high. Okay, there is a guy standing over here. It is 7 meter. Okay, now he has to catch the kid at particular this distance. Okay, This is 1.8 meter. So this particular part is going to be 10 meter. Now the kid is here, right? And he is going to be fall downward. Okay, so initial speed is taken to be 0, height is 10. Now we have to find time. Okay, so h is equals to ut plus half gt square. Is half gt square. Height is 10. This is half. Okay, we can take z as 9.8 into t square. So this is 20 by 9.8 equals to t square. This will be 200 divided by 98. Okay, so this can be written as 100 divided by 49. So t can be taken as 10 by 7 second. Okay, so after 10 by 7 second, kid will be this at this particular point. Okay, now this man has to cover this much distance, which is 7 meter. So and his speed should be uniform. So I can take v equals to d by t. Distance is 7 meter and time is 10 by 7 seconds. So this is 49 by 10, 4.9 per second. So the speed of this particular young man would be 4.9 meter per second to catch this kid. Otherwise, the kid is gone. So his speed should be more than the 4.9 meter per second. It should be 5 meter per second, 5.1, whatever can be the value, but it should be more than 4.9 meter per second to catch this kid. Okay, so that's all for this particular problem. Okay, our next problem is an NCC parade is going at a uniform speed of 6 km per hour through a place under a berry tree on which a bird is sitting at a height of 12.1 meter. At a particular instant, the bird drops a berry, which cadet give the distance from the tree at the instant will receive the berry on his. Basically, such kind of problems has so many description, and basically you have to focus on the numbers, 12.1 and 6 km per hour. Okay, so there is a tree. It has a height of 12.1 meter. So here consider a berry. It is at 12.1 meter height. Okay, now it is going to fall downward and will reach here. Okay, so we have to find time for this particular drop. Okay, so height is 12.1 equals to half g is 9.8 square. 121 into 2 divided by 98 equals to t square. Okay, so I can write it as t can be 98 can be cancelled at 49. T square can be written as 121 by 49. T will be basically 11 by 7 second, right? 6 km per hour can be written as 6 into 5 by 18, right? So this will be 5 by 3 meter per second. So this speed of the NCC parade is 5 by 3 meter per second. Now NCC parade is going at the uniform speed of 5 by 3 meter per second. So I can put v equals to d by t. So d equals to what will be v into t. V is 5 by 3 and t is 11 by 7. So d will be 55 by 21 meter. Okay, so you can find it as, so answer of this d will be 2.6 meter. Okay, so that's all for particular problems of motion under the gravity. Okay, so stay connected to the channel for further videos of kinematics. Thank you so much.